Okay, we're looking at problem 1 here and trying to find the intersection of these two lines. So I've already graphed y equals 2x minus 3 and 4x minus y equals 9. And up on Desmos comes my picture. Now all I need to do is take my cursor and tap right in here, and it'll show us, usually if you tap right there, it's going to give it to you. Hey, they intersect at 3, 3. So for problem 1, our intersection is 3, 3. If we go to problem 2, now I've graphed all these ahead of time. So here's problem 2. Open the graph. I graphed them. Here we are. How do I find the intersection of the two lines? I just tap right in here and it's going to show you 2, 1. They intersect at 2, 1. 2, 1 is on both those graphs. So that's the answer to problem 2. So far we don't have anything tricky. Here's problem 3, a little bit trickier. Now, I might have to pinch in a little bit or pinch out or zoom out or zoom in on this guy. I'm going to zoom in a little bit here, try to, using one hand is a little tricky. And we're looking for the intersection of these. So I need to scroll because I can see there's that blue line crossing. And I do know blue is a straight line, the other is a parabola. This is intersecting, looks about right there, -3, -15. But I think it's going to cross the guy further up also. So I might want to scroll and try and find way up here, they're going to cross again. And again, I could pinch in, but it's hard with one hand here. Struggling a little bit. So they intersect about right in here. It then puts the point of the intersection 420 is the other spot where they cross. So that's 2 answers for number 3. For number 4, if we graph it, let's open the graph. There it is. Ooh, this is a pretty one parabola facing upwards, the other facing downwards. They intersect right here at 1.414, comma 2. Now I'm going to tell you that 1.414 is actually the square root of 2, but you don't need to know that. You can just write approximately 1.4, comma 2, and then over here, it's negative 1.414, comma 2, which is really just the negative square root of 2, but we don't need to know that. Problem 5. Click on number 5, open that graph. I've graphed 2 parabolas here. What's interesting is they intersect right here. We see that. Click it, -1, 0. But do they intersect anywhere else? The answer is, as we keep going, no. They pretty much, if you look at it, stay, they're not straight lines, but they pretty much are what? Parallel. They're never going to intersect up top. So there's only actually one intersection here for number 5. Number 6. What did I graph? Well, you'll notice when we did x squared plus y squared equals 4, you should have gotten a circle. Okay, now we're going to have 4 points of intersection here. There's one right here at 2, 0, seems to have an intersection. There's one right here at 1.732, comma -1. And then here are my other ones over on the other side of that parabola. You'll notice the parabola is going to hit, because a parabola is symmetric, a circle is too. So it's going to end up hitting in sort of the positive sides and the negatives. So there's your answers for that. Number 7. Ooh, look what I did. Instead of a circle of x squared plus y squared, I did x squared minus y squared, and it formed this. Now let's look here, because this gets a little interesting. We have point of intersection at 2.236, comma 1. Again, just and 2, 0, and then it's going to be the negatives on this side. If you think of that, when we subtracted, it sort of did the opposite of a circle. Instead of closing in that direction, it went the other. Okay, we actually will study that later on, but not today. Let's get to the final graph. Number 8, look what I created here. Woo! We have a circle, and then we have a x to the 4th, which forms a W. So it does a parabola, but it has an extra hump in the middle is what always happens. If you do a W6, it'll have a second hump, and W8, 3 humps, and so forth. That's what usually happens. So we're going to have 7 points here. We have one right here, 0, 2. We have one right here, negative 1.9 and 0.618. Not that. That doesn't intersect, does it? I just tapped on it. We have this. It does cross the red and blue. You can see it intersect at negative 1.7, negative 1. We cross here also, negative 1.176 and negative 1.6-ish. That, nope, that's just where it's crossing the y-axis. Here, that is an intersection of them. There's an intersection. And there's my final intersection. Should have 7 where they intersected, because remember, this was not 1, nor was that. So there are our 7 intersections. Pretty cool. You can imagine how difficult they would be to do if you were doing it by hand. So here, Desmos really does help us see the points of intersection.